Hi, I'm Alshin. So I will tell you what is the amplitude modulation (AM). Modulation is the message that itself is a signal. Amplitude modulation is a process by which the wave signal is transmitted by modulating the amplitude of the signal. If you want to know how to draw the waveform for the amplitude modulation signal, you need to know these three formula, which are modulating signal, formula, carrier signal formula, and also amplitude modulation signal formula. Not only that, you also need to know that what is the modulation index. Actually, modulation index is M, which is amplitude modulating signal over amplitude carrier signal. This will be the waveform for double sideband full carrier. And you need to know what is the modular sideband, carrier sideband, and if you want to find the lower sideband frequency, you can use FC minus FM, which is frequency carrier minus frequency modulating. And if you want to find the upper sideband USB, you can use FC plus FM, which is frequency of carrier signal plus frequency modulating signal. And there are five types of amplitude modulating signal. The first will be the double sideband full carrier, double sideband suppressed carrier, single sideband, single sideband suppressed carrier, and also the vestigial sideband signal. If you want to know what is the difference between the five types of the amplitude modulation signal, you can refer to this slide. Double sideband carrier is got two sideband and one carrier, but the double sideband suppressed carrier is remove one the carrier, but single sideband got one sideband and one carrier. If you want a single sideband suppressed carrier, you need to remove the carrier and only one sideband is left. And what is the vestigial sideband? Actually, vestigial sideband is a compromise between DSB and SSB.
Hello, my name is Nur Afifa Zaida. So next we will discuss on the topic of angle modulation, a way of changing a carrier wave to send information. It's like adjusting the direction or angle of a wave to ensure the melody reaches our ears crystal clear. There are two types of angle modulation, which are frequency modulation FM and phase modulation PM. So next we focus on PM, which is phase modulation. In PM, we alter the phase of the carrier wave based on the amplitude of the modulating signal. Think about the starting point of a spinning wheel. In PM, the starting point of the carrier wave changes with the sound. It's like telling someone to start spinning the wheel a bit later or earlier depending on the music. Mathematically, PM can be represented as the diagram below. The phase sensitivity, which is Kp, plays a crucial role as it determines how much the phase of the carrier wave changes based on the amplitude of the modulating signal. So higher values of Kp resulting in a greater phase shift in response to changes in the modulating signal. Comparatively, PM and FM are interchangeable. From the signal itself, it is challenging to distinguish between them. But the key point is to remember that PM alters when a wave starts and FM alters how fast it occurs. More information on FM, I will pass the explanation to Wong.
Hi, my name is Wong Wei Heng. I will explain what is frequency modulation. Frequency modulation is a method used to encode information in a carrier wave by varying the frequency of the wave. In other words, it is a modulation technique where the frequency of the carrier signal is changed in proportion to the instantaneous amplitude of the input signal, which is message signal. Here are the examples of frequency modulated signal, which has a higher number of waves over a period of time. Here is the mathematical equation of the FM, where EC is the amplitude of the carrier wave, omega c is the carrier frequency, and beta is the modulation index. Figure 1 is an example of the frequency spectrum. Based on the frequency spectrum, we can obtain number of sideband and modulation index based on the Bessel function table. For instance, first frequency spectrum only has one sideband, which is J1. Therefore, based on the Bessel function table, the modulation index is 0.25. Cousin rule. named after John R. Carson, provide a guideline for determining the bandwidth of a frequency-modulated signal. The rules help estimate the bandwidth required to accommodate the frequency deviation in an FM signal. Here is a formula of bandwidth, where this symbol is the peak frequency deviation, which is the maximum difference between the carrier frequency and its instantaneous frequency due to modulation, where Fm is the maximum frequency in the modulating signal, which means that the higher frequency component in the message signal. Differences between amplitude modulation and frequency modulation are: in amplitude modulation, the amplitude of the carrier signal changes based on the data signal, whereas in frequency modulation, the carrier wave frequency can be changed based on the signal that holds data. Amplitude modulation are more liable to noise, whereas frequency modulation is less liable to noise. The sound clarity of amplitude modulation is poor, however can transmit a long distance, whereas frequency modulation has high bandwidth including good sound quality. Amplitude modulation includes simple two sidebands, whereas frequency modulation includes a number of sidebands.
Hi, my name is Ahmad Zafri and I will continue to the next topic, which is Pulse Code Modulation or PCM. So PCM basically is a method used to digitally represent the analog signal, which is by sampling the amplitude of the signal at a regular interval and then quantizing the amplitude values into the discrete symbols. So rather than we modulate the signal physically like AM, which is amplitude modulation, or FM, frequency modulation, we use digital modulation, which are very essential as more of the telecommunication network nowadays are moving toward to the digital world. So some advantages of digital modulation, which are immune to noise, easy storage and processing, and we can use the error correction detection. So in using the PCM, the synchronization is very important to allow the effective transmission at the receiver. So as you can see, the block diagram shown below, which is the encoder and decoder that used together with the ADC and DAC, which are analog to digital converter and digital to analog converter to transmit the digital digitally. So back to PCM, some of the PCM applications which are telecommunication that we use in digital telephone network for voice transmission. The next one is for the data transmission, which the PCM had been utilized for transmitting data over various digital communication system. And the last one for the audio recording, which is very common nowadays as we can use it to digitally audio record and playback system. There are three key components in pulse code modulation, which are sampling, quantization, and lastly encoding. So for the first one is sampling. In sampling, we are regularly measuring the amplitude of the analog signal at specific interval, and the analog signal must be sampled at least at Nyquist rate to avoid aliasing. So for this one, the Fs, the sampling frequency, must be more or equal to the 2 times of the modulating frequency, Fm. The basic of sampling, we got 3 types of it, which are natural sampling, ideal sampling, and flat top sampling. The figure shows the 3 types of sampling, and in every sampling method, the pulse amplitude is directly proportional to the amplitude of the information signal. The next one is quantization. So basically, we assign the discrete value to the sample amplitudes, turning the continuous signal into digital representation. So the number of level, maximum and minimum value of analog signal will be fixed. And the number of level determined by the number of bit used. So there are a few parameters that we need to know in applying quantization, which the first one is the quantization level L. So it is equal to 2 power of n bit. So as shown in the figure, the level represents on how many segments will be divided the peak-to-peak voltage. And the next one is the quantization interval, where we find the magnitude of difference between the levels, and the quantized value, which is the middle value for each segment. So bear in mind, this is only for the uniform quantization, and for non-uniform quantization, we need to apply the compounding technique. So this will allow us to produce a uniform signal-to-noise ratio (SNR) for all input range. So for the compounding, it will involve the process at the analog compression at the input, and expansion at the receiver. The last one is encoding. In this part, we represent the quantized value in binary code. So the binary 1 and 0 in PCM signal can be represented by several formats known as line coding. There are a few considerations for line coding formats such as transmission voltage and level, which is either unipolar or bipolar that can affect the power efficiency. The duty cycle, the ratio of the active bit time over bit period, the bandwidth that will depend on the transition of the bit sequence and synchronization, the affordable amount of transition needed, and then lastly, error detection and correction, which is the mechanism that coding can provide.